Hello everyone. Today we have the capital budget problem in which we have multiple projects. In this case we have 20 projects and each project is associated with a net profit value which we try to maximize. So in this problem we try to select projects that maximize the net profit value while we have some constraints that we need to adhere to. One of these constraints is the cost. So each of these projects will impose a cost for year 1, for year 2, for year 3, and the summation of these costs should not exceed that limit for each year. Also, we have the constraint of the labor. So each of these projects will require a specific labor. So we should not exceed that labor constraint for each year. So first of all, we start by importing the libraries that we import every time, and in this time I'm going to be reading the data directly from the sheet that we have, the Excel sheet. So I will need to upload that data, and after uploading the data I will need to read it. So I'll give the path, I'll call it like file path is going to be, I'll copy the path as it is and paste it over here, and now I will run this. So I get the path, I will read the data, which is pd.read excel from file path, and let me print out my data. So here is the data that I have. It's exactly the same that we showed at the beginning of the project, the beginning of this video recording. Then I will need to extract the budget from this data. So we have columns, this is 0, 1, 2, 3, and 4. These columns give us the budget. Or the constraints for the cost. So I'm gonna say budget is equal to data.eloc. I'm going to do slicing. I will take row 0 and then columns 2 through 5. So we start by 0, 1, this is 2, 3, 4, and the last one is not included, 5. And this is the convention in Python. I will take the values, and here is the budget I got. I will do the same to get the labor availability, and I will call this data.eloc iloc 0 starting from 5 to the end. This is going to be 5, 6, 7, so it's going to be row 0, then 5 to the end with values. I got my labor availability. After that, I will extract the data itself for the project. So I will extract all of this data starting from this row to the end, to this row. I will do that through slicing. So I will say project data is equal to data.iloc 1 to the end. So I will take all the rows starting from 1 to the end, and I can set all columns. I will do something which is technical. I will just reset the index. So instead of starting from 1, because if I slice it, it will start from 1, it will start from 0. It will reset the index for me. .reset index, and I will drop the main one. Now I get my project data. I will now extract from my project data the net profit value. So it's going to be the project data, and from that I will extract the net profit value column and PV dot values. This is net profit value. After that I can extract the cost for each year. This is the cost for year 1, cost for year 2, 3. I will do so also for the labor 1, 2, 3. I can do that actually very easily. I will just slice it like this. Cost for year 1 is equal to project data cost, this the name of it, cost year 1. I can just copy it from here. Dot values. I can copy and paste this 3 times. I will change this from 1 to 2 and this to 3. Now I will change this. I'll copy and paste this. I will do it for the labor. So labor year 1 is going to be labor year 1. I'm just taking the label from here. And I can, it's going to be easier for me to copy and paste this and change the numbers. This is year 2, this is year 3. Yeah. So far it was extracting some data. I will now define the number of projects I have. I have actually 20 projects. And I will start building the model. So all the previous step was just to extract the data based on which the model will be solved. Now I will define my model as GurubyPy.model, same as we do every time. I will give it a name. I'll call it capital budget. We'll run this one. Now I will define the constraints, set the objective, define the variables, and solve the model. So I will start by defining the decision variables. Model.add vars. I will have 20 variables actually. So when you just add the number, which is here 20, that will inform Guruby that I have 20 decision variables, and they have the type that you will enter here, and here in this case they are going to be binary. So either we select the project and that's going to be 1, or we don't select it and that's going to be 0. So it cannot take any other value like real value, in which we have in linear program, or any other like integer value other than 0 and 1. And I'll give it a name of X. After that I will set my objective. Let me just run this one. Now I will set my objective. It's going to be GurubyPy.quick sum, and I will multiply each project, each decision variable that I have by its net profit value, and I will try to maximize that one. So each project is defined as X. I will multiply it by its corresponding net profit value, and I will sum these things together. This is going to be for each project in the number of projects I have. So I have 20 projects actually, and I will give it a sense in this case because it's maximizing and the default is minimizing. You need to define the sense, which is maximize. I have now set the objective, and now I will just add the constraints. I have two types of constraints. Here I have 3 constraints. So the multiplication of each project by the corresponding cost for year 1 and summing that up should not exceed 2700, and that applies for year 2 and year 3 as well. So I will just do that. Constraints GurubyPy.quick sum cost year 1 So for each of these costs I have for year 1, which are defined here, starting from here, I will multiply that cost with the corresponding value of the decision variable. For each project in range of all projects, I can just put it 20 projects. This is just for clarification. So the multiplication and the summed multiplication should not exceed for year 1 2700, and this is going to be the budget that I have defined here. I will take the first value of it, budget and I will take just the first value of it, which is 0, and I will give it a name if I want. Name is going to be budget year 1. I can do this 3 times for the 3 years. I can just change this to year 2, this to year 3, and this is going to be 1 for year 2, this is going to be 2 for year 3. Now I can do exactly the same thing. I will just change the names here, 2 and 3. I will do exactly the same thing, however this time it's going to be for the labor. So labor year 1 multiplied by the corresponding decision variable for each project should not exceed the labor availability, which is here for that year. Now I'm gonna copy and paste this 3 times. I will change this to year 2, this to year 3, and this is going to be this is going to be a labor availability actually. That's what we defined the constraint for year 1, which is 0, for year 2, which is 1, for year 3, which is 2. And I will change this to 2 and 3. I think we're good. Now what I need to do is just to solve the model, and I will just solve it using the method that we used before, which is model.optimize. And we get an answer for that. I can also print out the answer in a better way. So I can just define the selected projects as a list, then go over each project. So in this case I will just iterate over the indexes and the values and or decision variable. So for each index and decision variable in enumerate, so enumerate is used to get the indexes. So for each of those I will print the variable name and the variable value, and if the value is greater than 0, I will append that project. Selected project, which is this one, is going to be, I will append to it that project, which is project I plus 1. I add 1 because Python always starts from 0. So I will just append that one, and I will print out, oh sorry, this should be dot append. Yep. the selected projects, I can call it selected projects are, and then print out the selected projects. Oh, this should be V actually. Yep, so these are the selected projects: 2, 3, 6, 7, 8, 9, 10, 14, 15, 16, 19, and 20. And in this case, I can print out the objective value. And here is the objective value. This is for the first case actually. So I have other cases in which I will need to add maybe one constraint for each of these cases. So let me just put all of this in one code and call it case number 2. In case number 2, I believe we have one constraint, which is if we select project 3, then we must also choose project 4. Good. So I will copy everything into one cell, except for reading the data because it's going to be the same data. So the model itself, I'll copy this, paste it in one cell. After the model, I will copy the decision variables. They are the same, into the same cell. Then I will copy the objective function. After copying the objective function, I will copy the constraints. And I will copy the solve to a next maybe cell, and I'll copy the solution, printing out the solution, and printing out the objective value. However, in this case, as we said, I will start running this. I will not run this until I get the new constraint. So in this case, we have new constraint, which says that if project 3 is selected, then project 4 must be selected as well. So I will add one constraint, which is model.add constraint x for the project. If it is 3, which is 2 in Python, it starts from 0. If project 3 is selected, then project 2 project 4 must be selected as well, which means that the value of project 4 must be equal to or must be greater than or equal to project 3. That's what ensures us that we have higher value, or project 4 always selected when project 3 is selected. And I can give it any name. I can call it like project 3, 4, and then I can optimize and print out the solution. We see that in this solution we get slightly worse solution because we had more constraints, and the projects selected are different than the previous case based on the new data the model has, or the new constraints. The data is the same actually. Now we have the third case and the last one in this video, and in this case I would suppose that we can do only 4 projects from among the projects 1 to 10. So I will call it case 3. Only 4 projects can be selected among 1 to 10. I will paste the same model, same constraints. I will just remove the last constraint because it no longer applies to this case. I will add the constraint of that one, which is add constraint. So Gurubi pi dot quick sum, the summation of the projects I, for I in range, in this case it's just range 10. So for I in range 10, the summation of them must be less than or equal to 4. And I can give it any name like just for from first 10. After that, I will just solve the problem as I solved it previously and print out the results. So here's the objective value. It's less than the previous one because we have a new constraint. And here are the selected projects. That's it for today. Thank you.